Assalamualaikum and a very good day to our lecturer, Dr. Sharifah, and my fellow friends. Today, our group is going to present about part 3.1 from chapter 3, Catalysis and Catalytic Reaction Mechanism. My name is Nurul Shokina and my other group mates are Angel Alessandra and Nurul Ain. The definition of catalyst. A catalyst is a substance that increases the rate of reaction without itself being consumed. Often, only very small amounts of catalysts are required in a reaction. Catalysts work by providing an alternative mechanism involving a different transition state and lower activation energy. Catalysts may increase reaction rate or selectivity, or enable the reaction at lower temperatures. Catalysts do not change the extent of a reaction. They have no effect on the chemical equilibrium of a reaction because the rate of both the forward and the reverse reaction are both affected. This is an example of energy profile diagram. From this diagram, we can observe the effect of a catalyst in a hypothetical exothermic chemical reaction X plus Y to give Z. The presence of the catalyst, which is shown in red, opens a different reaction pathway with a lower activation energy. The final result and the overall thermodynamics are the same. Moving on, I am going to explain about the different types of catalysts. There is two types of catalyst, homogeneous catalyst and heterogeneous catalyst. Homogeneous catalysts function in the same phase as the reactants. Typically, homogeneous catalysts are dissolved in a solvent with the substrates. One example of homogeneous catalyst is the formation of methyl acetate from acetic acid and methanol. Meanwhile, heterogeneous catalysts act in a different phase than the reactants. Most heterogeneous catalysts are solids that act on substrates in a liquid or gaseous reaction mixture. An example of heterogeneous catalyst is vanadium oxide for oxidation of sulfur dioxide into sulfur trioxide.
Hello, I'm going to present about catalyst properties in chapter 3. Firstly, for the initiation of the reaction, as we all know that the function of the catalyst is used to increase the speed of the reaction rather than to start it and do not appear in the net reaction equation. The next is for the surface area and pore size. It is usually advantageous to have high surface area, which is large number of small pores, to maximize the dispersion of the catalytic components. The solid contains many tiny pores, and the surface of these pores supports the needed for the high rate of the reaction. A large interaction is important in attaining a significant reaction rate. This is provided by an inner porous structure. As you can see in the diagram, these catalysts are called porocatalysts, which are porous and non-porous catalysts. Then, for the difference between the catalytic promoters and catalytic poisons. Catalytic promoters is the substances which themselves are not catalysts, but when it mixed together with a small amount of the catalyst, it will increase their efficiency. For the example, Haber's process for the synthesis of ammonia traces molybdenum increases the activity of finely divided iron, which act as a catalyst. Catalytic poison is the absorbed species are not reactive. Their absorption will prevent further absorption of other species, making the catalyst inactive, which means it will destroy the activity of the catalyst. For the example, the platinum catalyst is used in the oxidation of the sulfur dioxide in contact process is poisoned by arsenious oxide. In addition, we should know that the catalyst doesn't change the equilibrium state of the reaction. A catalyst increases the rate for both forward and backward reaction equally. Hence, the catalyst doesn't influence the state of the equilibrium of the reversible reaction, but the equilibrium is attained earlier. For example, sulfuric acid is used as a catalyst in the ester hydrolysis reaction to speed up its reversible reaction. Finally, catalyst lowers the activation energy. Reaction occurs on account of effective collisions between the reacting molecules. For effective collision, it is necessary that the molecule must possess a minimum amount of energy known as activation energy. The catalyst provides a new pathway involving lower amount of the activation energy. Hence, larger number of effective collisions occur in presence of the catalyst in comparison to the effective collisions at the same time, at the same temperature, in absence of the catalyst. Therefore, the presence of the catalyst makes the reactions go faster.
Moving on to the last subtopic, which is catalyst mechanism. Okay, catalyst mechanism in a question form actually asking, how does a reaction happen? Okay, now we get a clear picture of the objective, right? How does a catalytic reaction happen? As we know, catalysts can be divided into two main types, which are heterogeneous and homogeneous. For the typical steps in heterogeneous catalytic reaction, there are 7 steps. External diffusion of reactant, internal diffusion of reactant, adsorption of reactant A, reaction of absorbed intermediates, desorption of the products from the surface, internal diffusion of products, and finally the external diffusion of products. The steps that are red color are the most important steps of reaction. Adsorption of reactant. The incoming species lands on an active site and forms bonds with the catalyst. It may use some of the bonding electrons in the molecules and thus weaken them and making a subsequent reaction easier. Reaction of absorbed intermediates. The absorbed gases may be held on the surface in just the right orientation for a reaction to occur. This increases the chances of favorable collisions taking place. And finally, the desorption of the products. There is a rearrangement of the electrons and the products are then released from the active sites. For a more precise explanation, I recommend to watch this video. She explains the 7 steps more precisely. Other than that, for the homogeneous catalyst, there are 5 important steps which I identify as linear. But for our level, we only need to focus on the 7 steps of heterogeneous. But if you are curious, you can click some of the links suggested somewhere in the description box. In conclusion, catalysts plays a huge role, especially in the chemical industry. So it is important for us to study them and understand the mechanism thoroughly. That is all from our group. Thank you.